So this video we're gonna go over the problems similar to the 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 ones on test 3 for your college algebra class. And test 3 is the test on the content for chapter 4 in your book. So the first problem here that we're looking at, it gives you this quadratic function, and the questions are to find the vertical orientation of the graph, the vertex, the y-intercept, the x-intercepts, if any, the parabola of the parabola that is defined by this function. Now, first thing is to find whether the vertical orientation of the graph is upward or downward. In this case, we're gonna say that the vertical orientation of the graph is upward. Now we're going to tell you why it's upward. Some of you may already know why it's upward. You may have seen on my answer key that I posted, I put upward. I don't know, for some reason, some of them I see downward. I don't know. I may have uploaded different. Oh, you see, I said upward and I selected downward. So basically it's upward. Why is it upward? It's upward. Oops. It's upward because the coefficient, this is ax squared plus bx plus c, right? And the value of a equals 1/2 is a number that is greater than 0. So that explains why this graph, it has a vertical orientation that is upward. Now we're looking for the vertex of this graph. The vertex is the turning point. So you have a curve that is like this because it looks upward. The vertex is the turning point. So the x value is h equals negative b over 2a. The x component of the vertex is h negative b over 2a, and then the k value would be f of h. Whatever you get for h, you plug it into the function, right? So let's find h first. So the x coordinate of it is negative 4 over 2 times 1. A equals 1, h equals 1/2. 2 times 1/2. So 2 times 1/2 is 1. So negative 4 is the value of x in the vertex. So my vertex, negative 4, comma, let's find f of negative 4 by plugging in. So that's 1/2 times negative 4 squared plus 4 times negative 4 plus 6. So that is 1/2 times 16 minus 16 plus 6. That is 8 minus 16 plus 6. So that's negative 8 plus 6, negative 2. So the vertex is negative 4, negative 2. Next question is to find out whether the vertex is a maximum point, is the max point of the graph or the mean point. So you can see clearly that all the graph is above the point that is the vertex in this case. So the lowest point of the graph would be the vertex. So it's the mean. But also the other way you can see that is that you can see by looking at the sign of A. If the graph looks upward, then you know you have a minimum. And also it's because the value of A that is in this case equals 1/2, it's greater than 0. So if A greater than 0, then you know that you have a maximum. The next, it says determine the y-intercept in XY format. Now, if you determine your y-intercept and you give it not in XY format, this is not the answer I was looking for. So you lose the point. So let's see here. How do you find the y-intercept? The y-intercept, you know, x equals 0 at the y-intercept. So then y would be f of 0. F of 0 is 1/2 times 0 squared plus 4 times 0 plus 6. This is 0, this is 0. So f of 0 equals 0. So your y equals 6, sorry, equals 6. So your y-intercept is x equals 0 and y equals 6. X equals 0 and y equals 6. So now that you have your y-intercept, let's move on to the next question where they ask you to find the x-intercept. What do you know about the x-intercept? The x-intercepts, you know, y equals 0. So then you're going to get f of x. F of x equals 0. It's the same as y. So 1/2 x squared plus 4x plus 6 equals 0. I hate to see fractions in my expression, so I'm going to multiply by 2 to cancel the fraction. I'm going to multiply by 2 so that the 1/2 can be canceled. So we have x squared plus 8x plus 12 equals 0. Now I'm looking for two numbers that multiply to 12 and add to 8. These two numbers are 6 and 2. X plus 2, x plus 6 equals 0. So we're gonna have two solutions for this equation, which will lead to two x-intercepts. So one value is when you have x, the first factor, x plus 2 equals 0. So x equals -2. And the other one is when x plus 6 equals 0. So x equals -6. We have two x-intercepts that we need to present in XY format. We already have y for both of them, y equals 0. So we're gonna go, the first value of x we had was -2, 0. And the second value of x, -6, 0, are the two x-intercepts for this function, for this quadratic function. Next question, they say, determine the axis of symmetry. Axis of symmetry, AOS. The axis of symmetry is that vertical line passing through the vertex of the graph, and I usually put it in dotted line, just for in dotted line, just to make sure that this is not part of the graph. It's just an element added to the graph. Axis of symmetry. And as you can see, it passes through the vertex of the parabola, which means the same x value of the vertex will be formed. I mean, this equation will be formed by the x value of the vertex. So x equals the axis of symmetry is always the equation of a line, not a single value. When I say an equation, I'm talking about an equal sign and two elements on both sides. So x equals the value of the x-axis, x coordinate of the vertex. So x equals -4 because -4 was the value of the x coordinate of the vertex of this parabola. Now, next question is easy to find because we already know these elements. We can just plug them in to find the vertex form of this function, quadratic function. So the vertex form would be f of x equals the value of a. If you go back, the value of a was 1/2. The value of h was -4, and the value of k was -2. So we can just plug them in to find the vertex form of this parabola. So that's 1/2 x minus -4, so plus 4 squared, minus the value of k was 2. So this is the vertex form, and you can realize that we don't even need to do anything if you already have a, h, and k. And last, use these elements so you can graph the function. So use these elements that we just found to graph the element. I'm gonna start with the vertex. What was the vertex? The vertex was -4, -2. -4, -2 is here. And I know the vertex passes through that. So I'm going to put it in dotted line just because I want to make sure we remember it. It's also a huge information for you, because with the axis of symmetry, if you have a point the same distance on the other side of the axis of symmetry will be another point, because when you're graphing, you're looking for as much enough points, I would say, so that you can follow the pattern of the disposition of these points. Now let's start with the x-intercepts. What are they? -2, 0, -6, 0. -2, 0, -6, 0. And you can see that these 2 points are as the same distance apart from the axis of symmetry. You can see that, right? Now, what is the y-intercept? The y-intercept was x equals 0, y equals 6. So x equals 0, y equals 6. And there would be another point on the other side, same distance apart from the x-axis, axis of symmetry. So that's 1, 2, 3, 4. So 1, 2, 3, 4. It will be here. Okay. Well, I believe that I have enough points to follow the pattern of this curve. So let me go ahead and see if I can follow the pattern. Come on. Okay, I have this side here. I'm gonna try to go with the second side. Yeah, so that's what I get. Well, I guess I can try better. Yep. Okay, so that is the graph of f of x. So that's the parabola f of x equals 1/2 x squared plus 4x plus 6. That's a parabola of f of x. And then next they say determine the domain. The domain of all parabola is negative infinity to positive infinity. And then the range would be from the lowest point, the y is 2, -2, -2 to all the way up infinity. So that is the range of this function, and that ends the first problem. In the next problem, we have this situation, right? We have this situation. Stephen wants to build a rectangular pen, the part in green, rectangular pen for some farm animals. One side of the pen will be against the barn, so the side that is adjacent to the barn. So no fence is needed on that side. So we realize that we're not going to use any material to fence the side that is adjacent, the side of the pen that is adjacent to the barn. The other three sides, which is W, W, and L, will require fencing. If Stephen has 400 feet of fencing, that's all he has, 400 feet of fencing, find the dimensions that maximize the area. So basically, we need to know the formula to find the area of a shape like the pen. Well, they told us it's a rectangular pen. But clearly on the picture, we can see that it's rectangular, missing a side. And then the number of the amount of fencing he has is 400 feet. So we want to maximize the area. A equals W times L, the width times the length of the pen, right? But also we need to know, because since we know the amount of fencing available, then since we're going to put it on the contour of the pen, except for the side adjacent to the barn, we are trying to make sure we also think about the perimeter of this pen, which can be the sum of the sides except the one side adjacent to the barn. So that is P equals 2W plus L, right? Because one L is not needed. Well, P is that the amount of total fencing that we're going to use. So that's 400, sorry, equals 2W plus L. Now we can solve for L. So L would be 400 minus 2W. And we can get an expression only in W. That's why they say write the A of W. The expression in W is A equals A of W. A of W equals, when we replace the L in this formula, then your expression becomes W times the value of L in terms of W, 400 minus 2W. And we can even distribute to see clearly that this will be a quadratic expression. So that's W times -2. I want to put the square term first. So that's -2W squared plus 400W. So A of W is -2W squared plus 400W. Now that I have this thing set up, the other thing that we can think of is that this is a quadratic expression where we know talking about maximum would be the -b over 2a for the maximum length, I mean width for this pane, and then we can find the maximum length by plugging in the W max into A of W, and then end up having the answer for the maximum area. So W, the maximum width would be -b, which is 400, -400 over 2a. So by the way, that's a W squared plus BW plus C, C is 0. Okay, well, I don't want to keep it here, but C is 0. So the B is 400 and A is -2. So W equals -400 over -4. So that's 100. So W, the maximum length for this pen in this situation, is 100 feet. And then now, since we find the maximum length for it, because remember we were looking for the maximum dimensions, right? The dimensions that maximize the area. So, and the dimension that the W that maximizes the area is 100. Then we would find the length that maximizes the area as we plug in W into A of W. So that is -2 times 100 squared plus 400 times 100, right? And then we get L, or we can replace it. Let's replace it into L in the, and it wouldn't be a problem if you did what I did, but I prefer using this equation to plug it in. So L equals 400 minus 2 times 100, and it's simpler too. So L equals 400 minus 200 equals 200. So that's 200 feet for the length. And then the maximum area would be length times width, right? So did I say length times width? So length times width, so that would be 100 times 200. So A equals 100 times 200. So that equals 20,000 feet. I mean, that's not feet, right? Square feet. So that is what the problem number 2 wanted us to perform. The next problem, they give me a quadratic function has its vertex that is -3, -8. The function passes through the point -2, -6. And now they want me to write the function. Well, when written in standard form, the function is f of x equals ax minus h squared plus k. So in this case, this is standard form, but in our course, we call this form vertex form. Vertex form. We call this form vertex form. So written in vertex form, this is the function is this, where f of x equals, now we're going to write the vertex form, but I do want you to write it in standard form actually. So standard form is vertex form of this would be f of x equals, remember, if this is the vertex, so that's h and that is k. So that equals a x, this time it's plus h squared plus minus k is 8. Now, because the graph, the parabola passes through this point, then you can go ahead and this is f of x and this is x. So that's -6 equals a -2. Well, I need to replace the h by 3, by the way. So I forgot to do that. I changed the sign, but I forgot to write the plus 3. So plus 3 squared minus 8, -6 plus 8 equals a negative, actually 1 squared. So 1 squared is 1, so that's just a. So 2 equals a. So then you have f of x equals, a was 2, x plus 3 squared minus 8. So that's the vertex form. And in standard form, according to our course, we would have to distribute the FOIL the x plus 3 first, then distribute the 2 and combine like terms, right? So then that's f of x in standard form would be 2x squared plus 6x plus 9 minus 8. And then f of x equals -2x squared positive 2x squared plus 12x plus 18 minus 8, so that's plus 10. That would be the standard form according to our course. So now basically what you need to do is you need to pay attention to what we see here and what they want you to find and what you have for this problem. in the next problem, we will be working with a graph or the graph of the of a function, polynomial function, to solve an inequality. So, well, to find the parameters or to find the equation of the function, not to solve an inequality, but to instead find the zeros, multiplicity based on the effects of the intercepts, x-intercepts mainly, and the end behavior. So the graph of f below is complete since it displays all the roots, the end behavior, and the y-intercept of the graph. Use the graph of f to answer the following questions. Note x and y intercepts are integer values. Now, here it says list all roots with an even multiplicity. If more than one such root exists, use a comma separated list to enter the root. Write D and E if no roots have an even multiplicity. Now let's talk about it, right? So a root has a even multiplicity when the graph hits the x-axis and bounces. So it's like the graph was going down, hits the x-axis and go back. It touches the x-axis, but returns. And when you have a intersection with the x-axis with the graph, where the graph goes through the x-axis, did not return until later or never returns, you know that you have a multiplicity that is odd. The multiplicity is odd when the graph goes through, does not return after touching the x-axis. But one thing that I want you to know is at this point saying even, and you see how quick the return is, that means in this case, you have not only an even, for this one as well, even multiplicity, but your multiplicities are 2. Because not only it hits and turns, but it turns quickly. Because if it was 4, for example, you would have like some type of slow return like this and then go up. But because it is quick here, so we have only even multiplicity, and this even multiplicity is 2. So -3 and 3 are both zeros of multiplicity 2. Now, knowing that, it's a lot of information that you just have here, but later we'll talk about it. Let's look at the next step of this problem. It says now we are listing the zeros with the odd multiplicity. But these are the only zeros we have. But also we know if there was 0 with multiplicity odd, it would be zeros where the graph crosses the x-axis, not bounces. So DNA. y-intercept. Well, your y-intercept in xy form would be here, which means x equals 0 and y equals 9. If you put 9 only, you lose the point. And finally, it says find f of x. Well, you know the zeros, so you can write the factors. So 0 factor and multiplicity. Let me put multiplicity first before factor. Zero, multiplicity, and then factor. Okay, so we have negative 3, multiplicity 2, factor x plus 3, positive 3, multiplicity 2, factor x minus 3. So f of x will be a. We always need to have this coefficient. Until we find it, we don't know what it is. X plus 3 exponent multiplicity times x minus 3 exponent multiplicity. If multiplicity was 1, then you would have just a factor. And then now we can use the y-intercept to find a, because this is f of x equals 9, and this is x equals 0. So we come here with f of x equals 9, f of x equals 0. That's a. 0 plus 3 squared plus 0 minus 3 squared. So 9 equals a times 9 times negative 9, 9, because negative 3 squared is 9. So we would have that. We would have 81 a equals 81 a equals 9, or 9 equals 81 a. So a equals 1 over 9, not 9, 1 over 9. So f of x is 1 over 9 x plus 3 squared x minus 3 squared. In this next problem, it says use the leading coefficient test to determine the end behavior of the graph of h. Determine the roots of h and the multiplicity of each root. Also describe the end behavior of the graph at each root, talking about whether it's if you have a even multiplicity, then you have touching bounds. If you have an odd multiplicity, you have a go through effect. If a third root does not exist, enter D and E when appropriate. First, let's start with finding the leading coefficient of the function. Or leading term. Let's find the leading term. The leading term equals this -1 times x with the exponent on the outside, x with the exponent on the outside, and then x, if there was a coefficient not equal 1, we would use it too, x with the exponent on the outside. So that equals negative x to the 6th power. Now you have a positive leading coefficient and an even positive leading coefficient and an even degree. We got a negative leading coefficient and even degree, then you know that this graph would be falling on both sides, falling left and falling right. So then this goes with your answer here. Determine the roots. Well, for each factor, we have a root. So if we set x minus 3 equals 0, we get x equals 3. Set x plus 1 equals 0 for each factor, x equals -1. And then x minus 2 equals 0, x equals 2. These are the zeros. Now the multiplicity of the least root, which one is the least? -1. What's the multiplicity for -1? The least root is -1. The root is, the multiplicity is 1. The multiplicity of the greatest root is 3, and the multiplicity is 2. The multiplicity of the third root is, 2, multiplicity was 3, because the power. Select crosses the x-axis or touches the x-axis, then turns around to complete the second part of the statement below. At the least root, x equals -1, the graph crosses, because it was a multiplicity 1, crosses the x-axis. At the greatest root, x equals 3. What multiplicity did we had? We had a multiplicity 2. So we know that the graph should touch and 3. It crosses. No, it didn't touch and turn. It crosses. Oh wait, x equals 3. It's 2. Yeah, it touches and bounces. Touches the x-axis, the x-axis, then turns around. And the other 0 was 2 with a multiplicity 3. It does the same thing as 1 because both are odd values, odd multiplicity. Determine the y-intercept of this function. The y-intercept of this would be, in the y-intercept as x equals 0. The y-intercept at x equals 0 for the y-intercept. So that takes me to y equals -0 minus 3 squared, 0 plus 1 squared, 0 minus 2 cubed. So that takes me to negative 9 times 1 times negative 8. That is positive 72. So the y-intercept in XY format, x equals 0, y equals 72. Now we are trying to find out whether this function is even or odd. To find that, we need to calculate f of negative x. If f of negative x is negative 1, so if f of negative x equals negative f of x, then f is odd. If f of negative x is f of x, f of negative x is f of x, then f is even. Otherwise, it's neither. So then let's find f of negative x so we can make the conclusion. F of negative x equals, every time I see x, I put negative x. So there was a negative here, I keep it. Negative x for x minus 3, negative x plus 2, plus 1, sorry. And then negative x minus 3, 2. To the third. So for this one, there's a negative sign inside. Raised to the third power, it'd be still negative. So I can bring it to the front here. That will change the sign here. There's a square here that I forgot to put. And because this is a square, then when you square this negative sign inside that distributes over everything, it will change it to a positive. So this expression will be, after this, what we realize, then it will be just f of x is x plus 3, because the minus gets canceled for this one. Sorry. The minus gets canceled here. This minus gets canceled with this one. These two minus to keep the positive x positive 2. And then your final expression would be, well, actually, I can keep the negative sign so that this would be outside. So then you have negative x, negative x plus 3, because we factored out, then we squared the negative sign, it turns positive. We factored out this negative sign, it's the one we have in front here. So x minus 1. And we factored out this one, but it's still negative. So then it cancels with this one that was already in the front. So we had 3 negatives. That's why we got 1 left, and then we still have the negative on the outside. So x plus 2 to the third. But when you look at this, this is not f of x, right? So you would say negative f of x, and with the negative sign, it's not positive f of x. So then your conclusion is neither. Now we're going to evaluate this synthetic division and make sure we put the result in this shape, in this format. So let's make sure that these terms are in descending order. They are, which is good. And the bottom one, we're gonna set it equals 0 to find the number we dividing by on the outside. So that's -2. And we list the numbers 2, -3, 1, -1, 2, and -1. Okay, so 2 goes down, -4, so -7, -7 times -2, that's 14, 15, -30, -31, that's +62, +64, that's -128, and then that is -129. So that's your remainder here. So your remainder, we're gonna put it as remainder here on top, quotient in the front, and divisor in the denominator. So your quotient will be 2x squared, 2x to the fourth, because we had 5 exponent 5, 7x to the third plus 15x squared minus 31x plus 64, and then the -129 on top, x plus 2 in denominator. So that's 2x4 minus 7x to the third plus 15x squared minus 31x plus 64. In this problem, you are going to be asked to, you actually asked to find the rational zeros, the list of the possible rational zeros by using the rational zero theorem in the first question. So basically what they want you to do here, they want you to list the factors of the constant, over all the factors of the leading coefficient. Which is in this case 6. So we're going to list all the factors, positive and negative. So let's start with 1, 2, 3, 4, 5. Wait, 5. No, 5. 6. And 12. And then the factors of 6 are 1, 2, 3, and 6. And then we're going to list all of the different combination to find the rational zeros. So first, let's divide everything here by the first element in denominator. So that's going to be themselves again. So that's +1 plus minus 1, plus minus 2, 3, 4, 6, and 12. Now we're going to do the same thing for 2. Divide everything here by 2, except if we already have a number, we're not going to take it again. So first thing would be 1/2. 2 divided by 2 would be 1. We already have 1, so 3/2. 4 divided by 2 is 2. We already have 2. We don't need it anymore. 6 divided by 2 is 3. We already have 3. We don't need it anymore. And 12 divided by 2 is 6. We already have 6. We don't need it anymore. So we're done with the 2 dividing by 2. Now let's start dividing by 3. So that's plus minus 1/3, plus minus 2/3. 3/3 is 1. We already have 1. 6/3 is 2. We already have 2. And 12/3 is 4. We already have 4. We don't need it anymore. Now let's look at we did 6, right? We did 6. So we did 1. Oops. We did 1. We did 2. We did 3. Did we do 4? 4 divided by, oops. We were doing 3. We did 1, 2, 3. We finished 3 because 12 divided by 3 is 6 divided by 3 is 2. 2 divided by 3 is 2/3. 4 divided by, we need 4 divided by 3, right? That's 4 thirds. 6/3 is 2, and 12 divided by 2 is by 3 is 2. Is 12 divided by 3 is 4. So we already have that. Now let's see for 6. Let's do 6. That's plus minus 1/6. And then we have 2/3. 2/6 is 1/3. We already have 1/3. 3/6 is 1/2. We already have 1/2, right? 4/6 is 2/3. We already have 2/3. And 6/6 is 1. We already have 1. And 12/6 is 2. We already have 2. So that's it. So we can list all the zeros now. We have, you can just copy this over. And then 3/2. So that's the list of the zeros for this. Now next step, they want you to factor to find all the actual zeros. Well, we know that this list is a simplified list of the zeros that are only rational. If a zero is not rational, it's not listing here. So if it's a irrational zero, it's not going to be in the list. And if it's a complex zero, it's not going to be in the list. So we're going to try to see which of these are actual zero. So to do that, we need to completely factor the expression. So I would suggest that you go to your graphing calculator and type the function and then find some zeros, because that will save you a lot of time as you are taking a test. So you go to your graphing calculator, you graph the function, and when you pick one of the time it hits the x-axis as 1, 0, and then perform your synthetic division. One of the time it hits the x-axis would be 2. So at 2, the graph hits the x-axis. I'm going to perform the synthetic division for this value. X equals 2. So then we got 6, negative 23. I'm going to list all the coefficients of f of x, right? Negative 23, 3, 32, and 12, right? Drop the 6 times 2. The 2 outside will be 12. 12 minus 23, that's negative 11. Negative 11 times 2, that's negative 22. Negative 22 plus 3 is negative 19. Negative 19 times 2 is negative 38. And 32 minus 38 is negative 6. Negative 6 times 2 is negative 12. So we have a remainder 0, which means that x minus 2 is a factor. So I'm going to go here and start writing the function. So f of x equals x minus 2 is one factor. I'm gonna keep working with these numbers to find a factor. So obviously, using the same graph, you can find another time that the graph hit the axis. So let me go ahead and graph this function for you so you can see what I'm referring to when I say you graph your function. So that's my graphing calculator. I'm gonna type my function in it. The function was f of x equals 6x to the 4th, 6x to the 4th, minus 23x to the 3rd, x to the 3rd, plus 3x squared, plus 32x, and then plus 12. Obviously, oops. Plus 3x squared, plus 3x squared, plus 32 plus 32x, and plus 12. Okay, now you have your graph, your function typed in. When you graph it, when you're graphing, you need to make sure the window is well set up. So I like the Z standard for my coordinate system. So I put 3, And then it gives me this, right? So once you see that, you can see where all the zeros are. But you know what? Let me go ahead and set up my window 10. Okay, it's 10 by 10. So I graph it, and then so that. Now I see some zeros, right? But obviously I know that this is one of the zeros. So that's 0, 0, 1, 2. We had 2, and we see that 3 is also a 0. So since 3 is a 0, then I can go back using 3 to perform the division. But you can't just take x minus 3. You need to show how you find the division to find the remainder of the expression. So that is, I'm going to use the synthetic division here. Let me use the same setup. So we said 3, right? And then the numbers, because those are the coefficient of the new polynomial of degree 3, right? Because that would be x6x to the third minus 11x squared minus 19x minus 6, right? That would be the other factor here, but we need to continue factoring. So that's why I don't even pay attention to write it down, because I'm going to write the factors progressively. So drop down the 6 times 3, that's 18. 18, that is 7. 7 times 3, 21. 21 minus 19, 2. 2 times 3, 6, 0. So we have another factor that is x, x minus 3, right? And then you have this quadratic expression, 6x squared, because it was 3 degree, then it goes down 1. So that's 6x squared plus 7x plus 2. Coefficient of x squared, then you need to multiply coefficient of x squared by the constant term. So that's 12. What are two numbers multiplied to give you 12 and add to 7? So that is x, that is 4 and 3. So then you have 6x squared plus 3x plus 4x plus 2, and then factor by grouping, you would get factor by grouping. So GCF of the first group, that's 3x factor 2x plus 1. And the second group, GCF is, second group of the GCF of the second group is 4, actually 2 plus 2x, 2x plus 1. So 2x plus 1 times 3x plus 2. So these are the two other factors, because we had a polynomial of degree 4. So, and then you got the maximum factors you can have is 4. So you have 2x plus 1. So that's going to be the factored form of f of x, not the zeros yet. So factored form will be that, and 3x plus 2. Now from each factor you can get a 0. From this factor we already knew that -2 was a 0. I mean positive 2. Positive 2 was a 0. Positive 3 was 1. And from this factor, x, if you have 2x plus 1 equals 0, so x equals -1/2, right? So -1/2. And the third factor would be 3x plus 2 equals 0. So that's a factor that is a 0 that is x equals -2/3. -2/3. So we have all the actual zeros, and as you can see, all the zeros are also listed as the possible zero, right? Because they're all rational. If there was 0 that is not rational, then it would not be included in the list of possible rational zeros of the polynomial. In this next problem, they give you the graph of a rational function. It's a hyperbola. That's why you know that it has asymptotes. So they give you the graph of it, and they're gonna ask you a question. Eventually, they can ask you to find the actual equation of the function. But the first question they ask you is to find the equation of the horizontal asymptote. Well, the horizontal asymptote is HA, which is the horizontal line, dotted line they show you on the graph, right? Well, where does it pass? What number it touches? Is it a y value or an x value? If it's a y value, then you're gonna set y equals. If it's an x value, then you put x equals. Well, this equation is a y value because the dotted line passes through y equals 2. So y equals 2 is the equation of your HA. And then they also ask you for the vertical asymptote. Vertical asymptote will be the value of x that makes the denominator equal 0, right? So what is it here? It's -2. So x equals -2. Determine the domain. Well, you know the domain, looking at the graph, you can tell, but the domain will be all real numbers except the value that make the value or values that make the denominator equal 0. But we only have one value that makes the denominator equal 0, unless you had some holes, but they didn't talk about that. Well, if they did not talk about it, we assume that the only value that makes the denominator equal 0 is -2. So we're going to give all real numbers except this value. So means domain is from -infinity to -2, union from -2 to infinity. They also want me to give the range. The range will be all real numbers except the value that makes the value of the horizontal asymptote, the horizontal asymptote. So the range would be from -infinity to 2, union from 2 to infinity. Use the given information to determine a polynomial function that satisfies the given characteristics. Well, they say the degree is 5, the zeros are 2, I, 1 plus 2i. But we need to remember, when you have complex numbers, their conjugate are also zeros. Okay, because if you have a degree 5, then you need 1, 2, 3, 4, 5 zeros. So that's why you need to always remember, when you have complex numbers as 0, their conjugates are also zeros. Now that you have all the zeros, you can set up the equation of your function. Never forget about this condition is to find the value a that you're going to have as a coefficient of the function. So f of x equals a times, for each 0 there will be a factor. So x minus 2 is one factor, x minus I is a factor, x plus I will be another factor for the conjugate, x minus 1 minus 2i will be a factor, x minus 1 plus 2i will also be a factor. Do we have 5 factors? Yes, we do. So now we have the next step, that's a, x minus 2. This is a minus b times a plus b. So that is, we're not going to forget that when you have a minus b times a plus b, it equals to a squared, not c. It equals to a squared plus b minus b squared. Minus b squared. So that can be written as x minus I squared. How about this one? We can do the same thing, but we need to be careful what we call A, what we call B. This is the A, this is the B, this is the A, same thing as the first A, and this is the B. The only difference is the plus and the minus, right? So then that's going to be, let me erase all this because I don't want to create any confusion. All right, and then that. Okay, so then that's going to be, let me put it in bracket, x minus 1 squared minus 2I squared. Okay, so then we have A times x minus 2 nope, that's I squared here and squared. I don't know what I did here, but yeah, that's A squared minus B squared. It's not A minus B squared. So that is x squared plus 1, because I squared equals -1, negative I is plus 1. Negative I squared is plus 1. Times, I guess we can put the parentheses now. This one, x minus 1 squared, is x minus 1 times x minus 1. When you FOIL, you should get x squared minus 2x plus 1. And then 2I squared equals 4 times -1, which is -4. And then -2I squared is +4. So that's +4. Okay. Now we have that, and then you can get f of x equals a x minus 2 times x squared plus 1 times x squared minus 2x minus 2x plus 5, right? And then now you can go ahead and plug in x for 1 equals 8. So you can use f of x equals 8. So 8 equals a times, we need to find a, 1 minus 2, 1 plus 1, because 1 squared is 1, times 1 minus 2 times 1 plus 5. So we will have, let me erase this. Hopefully you can, if you review the video, you can see it again. And then now we have 8. This is not part of what we're doing, but I just change the color because you need the formula. 8 equals a times -1 times that is 2, and that should be 4, right? So that's -2 plus 6, 4. And we have 8 equals -8a. 2 times 4, 8. 8 times -1, 8. -8. So -8 divided by -8, a equals -1. So f of x equals, replace a, x minus 2, x squared plus 1 times x squared minus 2x plus 5. If you want to distribute to get the standard form, you feel free to do it. But to me, I prefer the factored form. And then it's safer to keep the factored form, because if you choose to do the factored form and make mistakes on it, then you get yourself in trouble, because if you make mistakes while choosing to continue and break it down, I would take point off based on the fact that you make mistakes on your work or mathematical mistakes. So we want to solve this inequality, but we have an x squared, right? So we need to make sure that we move all the terms on one side, set it equals 0, find all the values that make the denominator equal 0, and then I'm going to show you how to fill in the table to find your solution. Basically, you're solving this expression. So you're solving x squared minus 7x plus 12 less than or equal to 0. Now, the fact that you have less than or equal to 0, then you're going to put bracket, because all the values for which this expression equals 0 will be included. Okay, so that said, we know that your intervals will be, your zeros, your solutions also will be included. Now, let's find the solutions of the equation x squared minus 7x plus 12 equals 0. We can factor this, right? Because if we factor x minus 3 times x minus 4, it's the same expression, because negative 3 times negative 2 equals 12, and add to negative 7. So you have the zeros, x equals 3, x equals 4. You have these two values that make the denominator go 0. Now, since we have the zeros, we can find the intervals, right? So the intervals are going to be from negative infinity to the smallest value, 3, bracket, because they are included. Another interval will be from 3 to 4, right? And then a third interval will be from 4 to infinity. So we have all the intervals, and now we're going to look for which one is a solution or which one is not solution, because we want the ones that only make this thing positive. I mean negative. The one that makes them that makes this expression negative. So we need a test point for each interval. So you choose your point. Nobody can tell you what to choose. You know what to choose, but you need to be smart when you're choosing, because when you choose, you can choose value that make it difficult for you, or values that make it way easy for you. So that's your choice. Okay, so now we're going to decide to see what numbers we're going to put in for each interval that we're going to plug into this expression, and to find whether the intervals are positive, the values of the expression x squared minus 7x plus 12 is positive or negative over each interval. And the ones that give me negative are the ones that I'm taking. So I'm testing here. Okay, so in this interval, I can take 0 because I know 0 is here, right? I would use 0 to test this interval. 3/4, 3 to 4, 3 to 4. We need to take a number, but this number should be in between 3.5, right? 7/2, which is 3.5. It's inside of this interval, and I can use 5. From 4 to infinity, 5 is one of the numbers. Okay, so let me test x equals 0. When x equals 0, that means I'm gonna plug in 0, right? 0 squared minus 7 times 0 plus 12. It gives me 12, so that is positive. So the sign here is positive. Let me test x equals 7/2, which is, and you can use your calculator to do that too, by the way. X equals 7, then 7/2. So that's 7/2 squared minus 7 times 7/2 plus 12. That is, use your calculator, that should give you negative 1/4, I believe, but try it. It should be negative 1/4. So that's negative. That's a negative number, right? So negative here. And then I'm gonna test x equals 5. Then that's 5 squared minus 7 times 5 plus 12. That equals to negative 2. This is also this cannot be negative. Let me see, positive 2. So that's 25 plus 12. That's 37. And then minus 35. So that's positive 2. So that's positive 2. This is a positive number. Okay, so having this, we can make the conclusions on which intervals are solutions, which are not solutions. So this one is not a solution because it's positive. We're looking for when it's negative, right? You remember? So that's not a solution. When I cross it out, that's not a solution. Put NS for not solution. This is a solution. And then this is not a solution. So your solution would be this interval, bracket 3, 4, close bracket. And we can graph the solution here because it's bracket 3, and then we put in a closed circle, and then 4, closed circle, bracket, and then it will be the interval between the two. Okay, so that is your solution here. In next problem, they want you to use synthetic division not synthetic division, the long division, and they want you to write your solution in this form here. So let's go ahead and set up the division. So x squared minus 2 is the divisor. And then you have the dividend, that is 2x cubed minus 3x squared minus 11x plus 6. That's what we're dividing by x squared minus 2. So we're going to start by dividing the leading term of the dividend by the leading term of the divisor. So that's 2x cubed over x squared. That equals 2x. And the 2x that you have here will multiply each term on the divisor side and subtract the result from the dividend. So that is 2x times x squared, that's 2x cubed. We subtract it here, 2x cubed. 2x squared times negative 2, that's negative 4x. Subtracted, it becomes positive 4x. That cancels each other. They two the same with opposite sign. So we got negative 3x squared plus 4x, we can combine these two, right? 4x minus 11. Wait 1 second. Yeah, 4x minus 11 would be 7. So plus negative 7, negative 7x. Okay. Now that we have this, because we need to combine like terms whenever we can. So that's why we combine 4x minus 11x. Okay. Then now what do you get? We can divide negative 3x squared by x squared, right? Because we need to divide the leading term here by the leading term right here. So we have negative 3, right? So that's negative 3. Negative 3 times x squared. That's negative 3x squared. We subtract it here, so it becomes 3x squared. Negative 3 times negative 2, that's positive 6. That's positive 6. We subtract it here, so it's negative 6. Okay, then that cancels each other, and you got negative 7x plus 6 minus 6. That's 0, right? And that is your remainder, because the degree of 7x is 1, and the degree of your divisor is 2. Makes the degree of the remainder here less than the degree of the divisor. Then it indicates that you need to stop the division right here. So then you can go ahead and write your the quotient plus remainder of a divisor form. You have your quotient, that is 2x quotient, 2x minus 3, divisor, that's x minus 2, and your remainder, that is negative 7x. So that's 2x minus 3 plus negative 7x over x squared minus 2. In number 12, what we are doing is we want to solve this inequality using its graph. That means you can solve using its graph, right? So basically, what you're doing when you're using the graph is, since the graph is given to you, then you're gonna make sure you indicate where the graph is, where this is positive or negative. But first, you need to indicate where you're solving this from, right? You're solving this to be greater than 0, not including 0. Not including 0. Okay. Now, because it's not including, then you're not including the part where you have the graph hit touching the x-axis. So the first thing we want to do here is we want to make sure we separate this graph into parts of the x values where the graph is above the x-axis, means positive, and where it's below the x-axis, which means negative. So basically, from negative infinity to this value, the graph, the function will be either positive or equal 0. Put this in green to mean positive. And then from negative 1 to all the way to infinity, you're gonna have the graph that is either positive or, negative or 0. But we're not solving for 0, right? We're not solving for 0. We're solving only for greater than 0. Well, what we're looking at now is that we need to make sure this indicates the right solution. So for x equals -4, it's 0. We don't need it. And for x equals -1 is also 0. And we don't need part where it's 0. We want part when it's exactly above the x-axis. So your solution will be from negative infinity to -4. We're not including it because it's not greater than 0. It's 0. The graph is the expression is 0 at this value. And then from -4, we continue to be above the x-axis up to until -1. So that's -4 to -1, which also we're not taking because the function is 0 at this value. So that's the solution. Here's another problem where we need to graph. We need to solve the inequality. But when you're solving an inequality like this, you need to make sure that you move all the terms on one side and 0 on the other side. So that's 2x to the third plus 3x squared minus 39x minus 20 greater than 0. Again, we're not including the intervals. We need to use parentheses because we have a greater than 0. We don't have equal. Now we want to find all the zeros. We need all the zeros of this expression on the right. So that means we need to solve 2x cubed plus 3x squared minus 39x minus 20 equals 0. We want to find all the zeros. Use test point just like we did in problem number 9, I believe. Problem number 10. So first we need to factor. Well, I suggest that you can find the zeros using your calculator if the zeros are all integers. But one thing you should do is that you need to find your way to find the zeros, all the zeros. In this case, you don't have to show me the step-by-step to find the zeros, but you need to find all the zeros. Well, I typed it in the calculator. I typed my expression, this expression, in my calculator, and I found that 5 is a 0, 4 is a 0, and there was some irrational zeros, so from fraction zeros, so I have to factor it. So let me use the 4 to do the synthetic division once, and then I will get a quadratic. Then I can factor it easily by with hand. So that's 2, 3, negative 39, negative 20. Okay, 2 times 4 is 8, 11, 44, 44, 5, and then 20. So 4 is a 0. Then this you can factor it as by grouping, because you're going to have x squared plus 11x plus 5. You multiply 2 and 5, that's 10. The two values that add up to this will be 1 and 10. So that's going to be x squared plus 2x squared plus 1x plus 10x plus 5. So common factor is x, 2x plus 1 plus I guess 5, 2x plus 1, and then 2x plus 1, x plus 5. So that will be the factored form of this equation would be x minus 4 x plus 5 and 2x plus 1 equals 0. So then all the zeros would be x equals 4, x equals -5, x equals -1/2. Then having the zeros, you can find the intervals here. So your intervals will be from -infinity to the smallest value, -1/2, with parenthesis because it's greater than, not equal. So you always gonna have parentheses when it's not equal, when you don't see the equal sign. So from -1/2 to the next, -5 first, sorry, -5, because that's the smallest one, and -5 again. Then now you're gonna have -1/2. Then from -1/2 to the next number, which is 4, and then from 4 to infinity. These are the intervals. Okay, I have my intervals and I need test point for each. You pick your test points. I pick for my test points -6, -1, 0, and 5. And when I test, I see, when I test, I see that the expression x 2x squared 2x cubed plus 3x squared minus 39x minus 20 is negative over the interval for x equals -6, means negative over the interval -6, -infinity, -5. It's positive for x equals -1, means that it's positive over the interval -5 to positive and to -infinity. It's negative for 0, obviously -20. For over the interval -1/2, 4, and then positive for 5, which means that it's positive from 4 to positive infinity. So this is not included because I'm solving for positive only. I will take this interval. I'm not taking this interval, and I will take this one. So the intervals that are solutions for this inequality are the interval from -5 to -1/2 and 4 to positive infinity. So that's my solution here. -5 to -1/2 union 4 to infinity. In problem number 14, they give me this parabola and they want me to give the equation in vertex form. But that should be an easy task. We know vertex form is f of x equals a x minus h squared plus k, right? Obviously a is negative because it faces down. We know the axis of symmetry is 1/2, right? Because you see where it passes through. Is it 1/2? X equals a 1 because it halfway from 0 to 2. But anyways, the coordinates, the vertex here, coordinates are x equals 1, y equals -2. So that's going to be a x minus 1 squared minus 2. We're almost there. Now we need a point so we can plug in, so we can find a. Let me use that one here. X equals 0, y equals 4, negative 4, right? For this point that I just pointed out. So that's x equals 0, y equals negative 4, which is the y-intercept. So that's x equals 0, y equals negative 4. So negative 4 equals a times 0 minus 1 squared minus 2. Negative 4 plus 2 equals, I subtract 2 on both sides, a. So a equals negative 2. So f of x finally is negative 2 times x minus 1 squared minus 2. Okay, so number 15, they give me a rational function and they're gonna ask me a question about it. So let's start with domain. Domain is all values, all real numbers except those who make the denominator equals 0. So the denominator equals 0 if x equals negative 1/2. So the domain would be from negative infinity to negative 1/2, not included, union, negative 1/2 to infinity. So now they say locate the asymptotes, vertical and horizontal asymptote. So the vertical asymptote will be x equals the value that make the denominator equal 0, 1/2, negative. The horizontal asymptote, h vertical asymptote, and the horizontal asymptote would be the value when you take the highest degree, the leading term of the numerator divided by the leading term of the denominator. The leading term, you have only one term in denominator, right? So that's going to be y equals 4x over 2x. X gets canceled, 2 gets canceled, then that's 2. Y equals 2. So that's your equation of the horizontal asymptote, right? Next, they say find the x-intercept. X-intercept, if any, right? X-intercept is when the top expression equals 0. So that's 4x equals 0, divide by 4. So x equals 0. Your x-intercept in this form would be x equals 0, y equals 0. Because when you plug in 0 here, then it'll give you 0. Anyways, we know that y would be 0 anyways for the x-intercept. Y is 0. And then now you have your x-intercept. We can find the y-intercept, right? The y-intercept is also 0 because when y-intercept is when x equals 0. And we already find when x equals 0, we had y was 0. So automatically f of 0 equals y equals 0. So that's 0, 0. The x and the y-intercept. And here we need you to find, I need you to find a few values that can help you find the pattern of your graph, right? So that's why I give you the menu to use your graphing calculator, TI-84 mostly, to find a table of values and use some values and put them in the coordinate system. Because when I'm grading, I don't care what numbers you put. I want to make sure that the numbers you put are numbers that are really in the coordinate if you plug in X, it'll give you f of X. And I would have my graphing calculator when I'm grading as well. Also, I want you to use different type of values, positive and negative, and eventually, since you already have 0, 0 as a intercept, but eventually you may want to use 0 as well as x equals 0, so you can see the behavior of the function at x equals 0. Since we already have 0, 0 as our x and y intercept, so we already have it a point, so we don't need to use it. So I'm taking -1, -2, 1, and 2. So the calculator gave me 4 for x equals -1, 8/3 for x equals -2, 4/3 for x equals 1, and 8/5 for x equals 2. Now I have enough information to graph my function, but I'm going to start with graphing my asymptotes. Vertical asymptote is -1/2. Vertical asymptote is -1/2. So that's a -1/2 right here. Okay, and I want it to be in dotted line. So that's my vertical asymptote, that is x equals -1/2. Also, I want to sketch my horizontal asymptote, that is y equals 2. Y equals 2. That's my horizontal asymptote, y equals 2. And then now I'm going to find the x and y intercept, that's 0 here, right? That's the y-intercept. And then we know for the asymptotes, the graph will try to touch, but never really touch. It will get closer and closer to the asymptotes, but never touch them. But we have some points that we can plot, and that will give us a better idea of the, of the shape of the graph. So -1, what is -1? X equals -1, 4, -1, 4. X equals -1, we got 4. And x equals -2 is 8 divided by 3. So 8 divided by 3, it's 2 point something. 1 point something. 1.666. So that's 2.666. 2.666. That means it's a little bit closer to 3 than 2, in between 2 and 3. So x equals -2, closer to 3, that means somewhere here. All right. So basically the graph would be a little bit like this, trying not to touch the asymptote. All right, so that's the first part of the hyperbola. And then we're gonna have another one. I know that most likely going to be over here in this region. But let me see, we have 1 4/3, 1 point something, 1.33 4/3, x equals 1, y equals 1.33. That means closer to 1, in between 1 and 2. So that'll be somewhere here, right? And we already see 2 point, we don't even need the 2.8 So 8 divided by 5 would be 1.6. 1.6, that means a little bit, x equals 2, a little bit up here, right? Okay, then the graph would be from the bottom of the vertical asymptote. It goes up, never touches it, obviously. And then we're gonna continue up, 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 passing through 0, 0, turns. It will go through these points here. And we know it's not gonna touch the vertical asymptote, the horizontal asymptote, but it would get closer and closer to this asymptote. So that's the graph of f of x. The next problem, number 16, they want me to use the rational zero theorem to find all the possible rational zeros of h of x, and then use synthetic division to test and find the actual zeros. Well, let's go ahead and find the actual zeros, p over q, the possible zeros, p over q. So plus minus 1, plus minus 5, right? That's it for that one. I'm looking for the factors of the constant. And then the bottom one is plus minus 1, plus minus 2, plus minus 4. That's it for this one. Now let's separate them to see how it is. So plus minus 1, plus minus 5 when I use this. Plus minus plus minus 1/2, plus minus 5/2 when I use 2, and plus minus 1/4, plus minus 5/4 when I use the, oh, we didn't use, okay, yes, we 5/4 when we use the second, when you use 4. And then the list of the zeros, possible zeros, is actually this one. So this is the list of the possible rational zeros. Okay, now we want to use them to find which one would work with to factor. So let's start with -1. We need to test them until we get 1. So -1, we're gonna divide x equal, coefficient of x cubed is 4, -8, -7, and 5. 4 times -1 is -4, so that's -12. Positive 12. 5 times -1, -5, so that's 0. So we have h of x equals x plus 1 times 4x squared minus 12x plus 5. Now we need to factor 4x squared minus 12x plus 5. Multiply 4 and 5, that's 20. Two numbers multiply to give 20 and add to give -12. That should be -10 and -2. And then we would write 4x squared minus 12x plus 5 minus 12x. We need to break it down as -10x, -10x minus 2x, negative 10x minus 2x plus 5. So factor out 2x here. So that's 2x minus 5. Factor out negative 1, 2x minus 5. So that is h of x equals, that's 2x minus 1 times 2x minus 5 equals x plus 1, 2x minus 1, 2x minus 5, right? And then we can list the zeros and their multiplicity. The zeros are negative 1, 1/2, and 5/2, right? All listed in the possible zeros, and multiplicities are 1, 1, and 1. So that's what they wanted me to find. In number 17, they give me this graph and they want me to list the zeros and give the effect on the y-axis. So I'm going to make a table quickly. I put the zeros here and the multiplicities here. And then the effects. Okay. 0, 0, 0, 0. So we have x equals negative 3, x equals negative 2, x equals 2, x equals 3. Since all these zeros, they just go through, they don't bounce, so multiplicities are going to be all ones, and the effect is all same across the x-axis. Obviously, since the multiplicities are ones, we did not expect otherwise for the effect. All right, the next problem, number 18, is the same concept as the one of the problem, number 2, I believe. So let's see what it says. Here it says a rectangular field will be fenced on all 4 sides. There will also be a line of fence crossing the field. A line of fence crossing the field parallel to the shorter side. That means something like this. Something like this. Okay. Well, I don't think you can see it well. Let me put that instead. Yeah, that's something like this that will cross it. That means another layer of fencing that's going to be added on top. That means you're going to need more materials to get this done. So 3 times the size of the shorter side. That's pretty much how much you need this length to get this done. And they say if 900 meters of fencing are available, what is what dimensions of the field will produce the maximum area? What is the maximum area? So they asked me for all these information, but that's the same concept. The only difference is that in the first problem we did, we had to subtract one side, but in this one, we double, we put a side more than one, more than two. So what do we have? So we know that W, 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 L, and L. So that means you got 3W plus L equals 90. And then you know that the area is always W times L. From this, we can solve for W. For L, that is easier for L. So L equals 900 minus 3W, and bring it back into the A equation. So that's A equals W times 900 minus 3W. So A equals a quadratic expression, or we can even call it A of W equals 9, let me put negative 3W squared plus 900W. And since A is negative, we know that is going to be a maximum. Now, we can find the dimensions that maximizes this quadratic function, because we know that's the vertex, and W is easier to be found because it's negative B over 2A. So W equals negative B over 2 times A. That equals negative 900 over negative 6. Negative 900 divided by negative 6. That's 150. 150 is the W, the length that maximizes the area of this field that we want to fence. And the W, the L will be easy to find by using this relationship. L, between L and W. L equals 900 minus 3 times 150. So L, the length that maximizes this, the area, will be 900 minus 3 times 150. So that is 450 meters. Okay, so we found the W that maximizes. We found the length. W was 150. Put it down here. 150 meters. The length was 450 meters. And then the area would be something in square feet, in square meters. So when you multiply W and W 150 meters times 450 meters is 150 meters times 450 is how did we get 450? Oh wait, yeah. So hey, hold on, there is a problem here. We want to take a look again back at that, because we should have 2W, 3W plus 2L. So then that divides by 2. Yes. And then when you plug in L, that also 2 in the denominator. And then, so that's 3 and 3. I mean 2. Okay, so yeah, we needed to consider this. So then negative b over 2a, negative b over 2a would be negative 900 over 2 times a negative negative 2 negative 3 over 2. So let's redo all this. Okay, so we have that. We can cancel the 2. So that is negative 900, I mean 450, negative 450 over negative 3. So negative 450 that still equals to W equals 150. All right, so meters. So that was okay, but we need to reconsider the value of the length, because we had this problem with the formula in the perimeter. So, and now what do? We should plug in 150 into this formula to find L. So L equals 900 minus 3 times 150 meters over 2. So that's L equals 900 minus 450 over 2. So L equals 245. Right. 450 divided by 2. 225. 450 divided by 2 is 225 meters. So that's 225 meters. And then now we have the length that maximizes the area, and the length that maximizes the area, and the width that maximizes the area. You can multiply these two to get the maximum area. So A equals 150 meters times 225 meters will give you something in square meters. So 150 times 250, 225, that's 37,750. 33,750 square meter. So these are the maximum. This is the maximum area, and these are the dimensions that get you to this maximum area. All right, so number 19, we have this solution, we have these expressions. We're going to state whether they are polynomials or not, and then you can tell why they are not. So this one, all the terms, there is no any all the terms, there's no denominator, variables in denominator, all the rules that you know, the 5 rules that you know. So this is a polynomial. Variables in denominator, this is not. Variables in radical, this is not. Variable in radical, this is not. Fraction, exponent, and negative, so this is not a polynomial. This is a polynomial because there is no issue with it. There's no issue, even if you see this, but there's no variable inside of the radical, so it's still a polynomial. Variables in denominator, that's not a polynomial. Even if you see the pi is not a variable, so pi is a number inside of the radical, cause no problems, so that's a polynomial. And then lastly, f of x equals x minus 1 squared times x plus 3, that's the factored form of a polynomial. No problem, it's a polynomial. So the last problem here is the same as we did in one of the previous problems. So you want to solve 8x squared plus 22x minus plus 12 equals 0. So we can find the solutions. So we can divide everything by, I guess, 2, right? 4x squared plus 11x plus 6 equals 0. If we multiply 4 and 6, that's 10. 10 is 1 plus 1 times 11. 10 is 1 plus 10. 1 times 10 is 10, and 1 plus 10 is 11. So we can factor 4x squared plus 1x plus 10x plus 6 equals 0. Equals 0. And by grouping, you can factor. So that's you can factor by grouping to get I guess x here. So that's 4x plus 1 plus factor by 2. Wait a minute. We factored let me see again. Divided by 2. Hold on, let's start it over. Let's start it all the way over. Sorry for that. We need to start it all the way over. So first, we need to move all the terms on one side. So that's 8x squared plus 22x plus 12 less than 0. Okay? And then if you divide by 2, that's 4x squared plus 11x plus 6 less than 0, right? Now let's solve it. 4x squared plus 11x plus 6 equals 0. We multiply 4 and 6. That's not 11. I'm sorry. That's not 10. I added, but we should multiply. So that's 24. 24. What are two numbers multiplied to get 24 and add to get 11? That's 8 and 3. So that's 4x squared plus 8x plus 3x plus 6 equals 0. By grouping, 4x factored out. So x plus 2. 3 factored out from the second group, 3x plus 2 equals 0. So we got x plus 2 times x 4x plus 3 equals 0. The zeros are x equals -2 or x equals -3/4. Okay. Now we can create that table, right, that we had, or we can do it on the number line. It's okay. So from negative infinity to we're gonna break the number line down to interval. We get that's negative 3/4. So that's -2. We have another interval that's -2 to -3/4, and then a third interval that is -3/4 to infinity, right? So that said, we have that, and then we can test. I'm gonna use -3 here, -1 here, and 0 here. And then when you plug them in, you're going to find plus, minus, and plus. So only one interval that would be the solution would be from -2 to -3/4 with a bracket, because I mean parentheses, sorry, because this was not including the solutions where it equals 0. And then the number line would be an open circle at x equals -2. Also an open circle at x that is 4/3. Is it 4/3 or 3/4? That's 3/4. 3/4, right? So then that's gonna be between 0 and 1, but closer to 1. Okay. Okay, and then that is your solution here. So that's your solution from -2 to -3/4. Okay, so that's the review. Hope you watch and take notes, and then get ready for your test.